Yes, please.
Yeah. So, so I welcome all of you in today's edition of the Data Dialogues. So, as some of you might be aware, Data Dialogues is a series of lectures uh, around the data spaces where we invite eminent people working in data spaces and try to figure out what they are doing and get their guidance and inspiration from them. Today, of late, we have been working at CDPG on open standards. One of those is the Open Geospatial Consortium, the OGC standards, right? Now, as you know, open standards are sort of foundational blocks which helps in unlocking the S&T, science and technology ecosystems, right? They help in interoperability, they help in transparency, and they also create a system and an ecosystem which actually encourages innovation. From a OGC point of view, which, as some of you might be aware, it's a globally adopted suite of open consensus-based geospatial standards. It continues to play a pivotal role in advancing science and technology domains around the world. It's very well established and very highly respected set of standards. Today, we have with us, and I'm very happy to introduce to all of you Harsha Madiraju, who is a global geospatial expert and advocate and is a widely known and networked geospecialist with over close to 20 years of experience in international marketing, in business development, creating strategic partnerships, organizational developments, and in non-profit management. Currently, he is the associate director and serves and supports member of communities in India and Asia Pacific at OGC, the Open Geospatial Consortium. So please join me in welcoming Harsha. And today's session, he will explore how OGC's freely accessible standards like data formats, web services, sensor standards, and APIs especially can support the India's science and technology ecosystem across governments, academia, research, industry, etc. Right? As you all will agree that we are going through a huge, change of ways where the government is also pushing a lot of these standards, and a lot of money is also being put in for research. So, not taking much time, I'll now hand it over to Harsha. And thanks, Harsha, for accepting our invite. I know you travel a lot and you are quite occupied. Please, you can start.
Yeah, thank you very much, JD, Namrata, and team for this invitation. I'm very honored to be here. I'll just wait for a second to confirm my slides are visible to everybody and I'm audible to everybody.
Yes.
Yeah, thank you very much for the confirmation, JD. Good afternoon, everyone. I'm delighted to be here as part of the CGPG and CSP data dialogue session to share some strategic perspective from the Open Geospatial Consortium, or OGC, as JD has just introduced. I'll be talking about on how open standards can play a critical role in advancing India's science and technology ecosystem. Our today's goal is to go beyond technicalities. I want to present a structured view of how India can move from data silos and fragmented infrastructures to building a future-ready, standards-aligned, interoperable digital science ecosystem, one that fosters innovation, transparency, and international alignment. Before I start, I also want to tell you that OGC is a non-for-profit organization, and CDPG is one of our members, and few of our members are also in the call today. Thank you all for joining this call. For those who don't understand OGC and OGC standards, this webinar would be a good introduction, and I'll be very glad to have further conversations with you and your organizations. So let's start. Let's begin by of open standards. First, they are foundation for innovation. Why I'm saying that they are foundational to innovation is it's not just in theory, but in how they let science and technology solutions scale, right? And think of them as plumbing behind the systems, talking to each other across formats, institutions, and countries. Second, they enable interoperability. Standards help different systems to work together without friction. And India's national geospatial policy explicitly emphasizes this, which is a significant signal. And third, they bring transparency and reproducibility. When scientific outputs use open formats, anyone can inspect them. This reduces ambiguity and strengthens trust in data-driven decision making. And finally, OGC standards, as again JD has mentioned, are developed by global consensus. That means they already reflect the best practices across government, industry, and academia. And India has an opportunity to align with that ecosystem while shaping its own needs through its own contribution into this ecosystem. So what you see here on this slide maps the breadth of standards, the OGC standard architecture. You'll notice that it's modular and covers the entire stack from abstract specifications, which are foundational blocks for all OGC standards, towards data formats and encodings, uh, web services, which are called OGC web services. Now we have OGC APIs, and also we have sensor interfaces. And these are we also have domain specific models like CPGML for 3D cities, WaterML for hydrology, and general purpose formats like GeoTIFF, NetCDF, GeoPackage, among many others. Again, services like Web Map Service, Web Feature Service, and now modern APIs make these formats accessible in web-ready ways. Importantly, OGC doesn't just create standards. What I want to say is it fosters architecture that is composable, allowing you as agencies, you as developers to adopt what fits to your use cases, providing a room for innovation as a layer on top of this standards-based architecture. So let's jump into a few of the standards that I want to talk from the perspective of today's webinar. The first one I want to talk about is a very well-known file format known as GeoTIFF. So anytime if you have used a satellite imagery, that means the format is known as GeoTIFF. So GeoTIFF is a OGC standard. It's used for as a baseline imagery format globally and in India. Nearly every Earth observation data set you see in ISRO missions like ResourceSat, Cartosat, RISAT is served as GeoTIFF via platforms like Bhuvan and now via Bhunidhi as well. So what makes GeoTIFF strategic is not just its ubiquity, not that it's just very prevalent across the community, but its compatibility, its universality, where all the commercial and open source tools support this format, allowing easy visualization, overlay, and pixel-based analysis. However, one of the potential gaps that I see in India is many research programs and even government agencies in India still publish their outputs, the derived outputs as static PDFs or normal images onto their websites, onto their reports. Shifting to GeoTIFF for sharing outputs will ensure analysis-ready access to the downstream customers, supports reproducibility, and enables integration with downstream workflows like additional modeling and validation. So this small shift in the ecosystem from the PDF-based outputs to GeoTIFF-based outputs will help us moving from a visual approach to an analytical delivery approach that can have outsized impact on transparency and reuse across the Indian scientific ecosystem. So this is my observation from the perspective of GeoTIFF. Now we have another standard. The next format is called the Cloud Optimized GeoTIFF, or COG for short. It is built on GeoTIFF, but it is engineered for efficiency in today's cloud-first world. So the users, instead of downloading an entire GeoTIFF dataset, let's say of terabytes of imagery, they can just request for an area of interest of their need, either in a web browser or in a kind of a Python package, so that the only needed tiles or bands can be queried. This is enabled by parallel querying and real-time rendering in web apps and notebooks. And this format is now being increasingly used in the India's private sector ecosystem, especially the drone firms which collect drone data. They ultimately publish the data as COGs, and even a lot of EO startups are moving towards COGs in their data sets and data management. However, in the public sector, COG adoption remains limited. So most data sets are still shared as standard geotiffs, while tools like GDAL and Python libraries already support local geotiff to COG conversion. That means the user has to download that terabytes of data onto their PCs and then use a converter on GDAL or Python for a geotiff to COG conversion. This barrier isn't technical, but it's institutional. So what I'm thinking is, if the public sector institutions can start publishing COGs, that will rapidly help not only on the server side, taking away the lot of load on imagery downloads and all, but also on the user side, where users would save a lot of time and bring efficiencies. So for government programs such as Smart Cities and Digital India, serving data sets directly as COGs enables seamless use in APIs and analytical tools. And researchers can not only consume COGs, but also should start publish their analysis outputs in COGs, closing the loop for reuse again, as I have alluded in the GeoTIFF example. So let's shift our focus from imagery towards 3D data models. Now 3D is a very much prominent topic, and CityGML is OGC's mature standard for representing semantic 3D city models. When we mean by semantic 3D city models, means that you can have buildings, terrains, infrastructure, all the related assets, along with their geometry, attributes, and hierarchies, managed in an open format known as CityGML. So globally, CityGML is already a backbone for smart cities simulations and energy modeling kind of use cases. So the video that you see on my screen here is actually looking at various kinds of modelings, right from energy modeling to food modeling to all these kind of modelings at a city level, at a data level. In India, the adoption has been slower, but there are green shoots, I should say. The Naksha project, as you all know, which is related to the urban cadastral mapping, undertaken by the Department of Land Resources and supported by the Survey of India, has now mandated CityGML in their procurement process as an output data format, signaling institutional strength to this format now in India. So as India moves towards digital twins, whether for urban planning, disaster resilience, or infrastructure modeling, standardizing 3D urban data is foundational, and formats like CityGML, and we also have a JSON variant now, which is a lighter version called CityJSON, allowing integration across agencies and enabling advanced applications that can be creating analytics on top of these data models. So I think there is an opportunity here in the research ecosystem led by leading academic institutions, state and urban local bodies to come together and work on pilot demonstrations to create city GML data sets, demonstrate their value for various use cases, and unlock the momentum for wider adoption of city GML in India. I will now talk about a format called NetCDF, which is actually a gold standard for scientific data that varies over space and time. What I mean by space and time is particularly the phenologies like climate, oceanography, and meteorology, where we have data sets where time and space, the data values vary over space and time. So for these kind of data sets in the climate, oceanography, and meteorology domain, NetCDF is a gold standard. And it supports rich metadata and is highly efficient in storing gridded multidimensional data sets. And this is why agencies in India like IMD, INCOIS, and Indian Institute of Tropical Meteorology rely on it to publish data sets such as rainfall reanalysis, ocean state forecasts, and atmospheric models, often spanning decades of data. So again, here there is a critical next step for Indian community. We must not stop at data access. That is, data is being published at NetCDF, while there is an opportunity again in the research community that the research outputs generated using the data sets, such as model simulations, derived indicators, predictions, should also be shared as NetCDFs. Again, not as petty maps. The outputs also should be as NetCDFs. Doing this will ensure full transparency and reproducibility, and it also will enable plug-and-play integration across tools, where that output product can then be consumed across the downstream, whether in a Jupyter or a GIS platform. Especially for long-term modeling, we need formats where consistency and metadata matter, and NetCDF can deliver that value to the community. So one more format I would like to talk about. It is called HDF5, and it's a very powerful format designed for complex, high-volume, multi-dimensional data. It's widely used in Earth observation missions where data isn't just large, but structured across layers, resolutions, and parameters. So the most relevant example I should say is the NISAR mission data. So we all know that the NISAR mission was launched recently. It's a scientific mission, and it's a collaboration between NASA and ISRO. And all the data sets from the NISAR mission will be published right from level 0 to level 3 radar products in HDF5 format. So these include advanced float-based pictures like raw single look complex, which we call as RSLC, or geocoded single look complex, or GSLC. So all these would be available in HDF5 format. And interacting with such data isn't trivial anymore. Why I'm saying that is because already we have a tool called SARPool tool, which is from made available by NRS ISRO, and we also have some QGIS plugins now, and also we have some Python packages such as H5Py, which are all essentially enabling this HDF5 to access NISAR kind of data sets. These integrations are already making it easier for scientists and analysts who will continue to work with NISAR outputs within their own familiar environments. For India's Earth observation and space research ecosystem, ISRO, SAC, and related agencies, standardizing around HDF5 wherever appropriate and investing in tooling and capacity building will be critical to make that these datasets are really useful and impactful across the ecosystems. While I have talked about various formats, I want to now talk about something called APIs. So what you're seeing here is a snapshot of OGC API standards family, a set of modular interoperable building blocks designed for the web. So these APIs aren't just replacement for legacy services. These represent a paradigm shift towards modern composable architectures. So each API here is narrowly scoped, purpose-driven, and aligns with the RESTful and JSON native principles. They can be independently deployed, versioned, and scaled, making them ideal for today's cloud-first environments which developers prefer. The green borders that you see on the screen indicate that each of these APIs have been formally approved as OGC standards. Others that you see, which are not not in the green border, are standards currently in progress and are underway through consensus process, which is a very rigorous process in OGC. Therefore, these APIs cover a full spectrum of capabilities, right from you want to discover a data set, you have a standard called OGC API records. You want to render map data, you have a standard called OGC API maps. You want to style your data, you have OGC API styles. And also for advanced functionalities like serving gridded coverage data, like as I said, we have seen some gridded data such as NetCDF, etc., but not a single NetCDF, but huge, large volume of such data sets. You can serve through gridded coverages, which is called EDR, OGC API EDR, which I'll talk in the next slides. And also we have on sensor data called sensor things, and also on geoprocessing and AI/ML workflows, we have something called OGC API processes. So what makes this ecosystem powerful is its flexibility. You don't need to adopt everything shown here on the screen at once. As a developer, depending on the need and capability of your tool set, or as a national agency, let's say if a national agency just needs to share vector data using APIs, they can use OGC API features. But if somebody wants to share sensor data, they can use OGC API things. Somebody wants to share data sets such as weather, climate models, etc., they can use OGC API EDR. So these kind of modular approach is there with the APIs. So this modularity supports incremental modernization, and it reduces the technical debt, enabling one is vendor neutral implementation and promoting reuse, the same standard being reused across domains, be it land records, urban mobility, disaster management, or even climate systems. So ultimately, these APIs help shift our geospatial infrastructure from isolated silos to an ecosystem of discoverable, accessible, and programmable services built for the web, but aligned, but also aligned for scientific and operational rigor. So I'll talk about one of such standards, API standards, which is called the OGC Sensor Things API standard, which is designed for not for traditional geospatial formats, but for real-time streaming data from sensors. So if you have any sensor streaming the data, how will you be able to collect the data and present the data easily, right? So it uses again a RESTful JSON-based model that can seamlessly connect to IoT devices and then bring the data and bring the data closer to the analytics platforms that we have. So the global examples already show a greater impact across numerous use cases. For example, the British Geological Survey in the UK uses this data for their borehole sensor data. So the demo that you just saw on the screen is from the British Geological Survey. Similarly, USGS has made all their hydrological data under Sensor Things API and made it available. And even in Taiwan for use cases such as analyzing disasters, air quality, urban traffic, and more, these standards are being deployed. Even in places like Germany for city traffic data collection and analysis, this standard is being deployed. In India, we have not seen anything like that. So we have a fragmented sensor network across domains, right? From air quality, we have the department like CPCB. For groundwater, we have CGWB. For weather, we have IMD. For geology, we have GSI. So how can we enable the data sets across the sensor data sets across these various organizations to come into a central platform, into an easy accessible way? So I think India has a great opportunity to explore OGC Sensor Things API, and with that we can, most of these operational silos and proprietary formats that these sensors rely on can be catered around. So Sensor Things API offers a standards-based bridge. With Python, the users can fetch live data using simple requests and analyze it in pandas or matplotlib and plug it into also the alert systems or other ML pipelines. So promoting Sensor Things within mission platforms or smart city control rooms can help unify India's sensor infrastructure into machine-readable, interoperable services, making them ready for analysis, dashboard, decision-making, and automation. The next set of standard that I want to talk about from my ED is the OGC's Environmental Data Retrieval API, which is a powerful standard for simplifying access to complex environmental data sets. This standard was developed by the UK Met Office, the UK Meteorological Office, and the US National Weather Service, and it became an OGC standard in 2021, and it is operationally used in most of the weather systems in the global north. What makes EDR special is its user-centric design. So let's say a researcher, an app developer, or an analyst want to query on a large volume of weather data. Say, what is the rainfall at a particular point in time? How is the data across a time series along a particular path? Let's say like a hurricane or a cyclone that you want to call it, or how is a weather profile over a city like Mumbai? So if you have to answer all these kind of questions, the data, if made available through OGC API EDR, can help various types of users to query, slice and dice the data into various various ways and consume the data. And also this removes the need for the user to understand in which format the data is being stored in the other end. All they can do is query the data and ask the data in the formats they need for their own analysis. For example, they want the data in GRAPE, or they want the data in NetCDF, so they can do that with this standard. So this is particularly transformative for climate and weather science. Today, many Indian platforms, for example, like MOSDAQ, India WRIS, and even IMD datasets require bulk downloading and then post-processing. So EDR offers a smarter model to address this issue, where you serve the data at once and make it queryable many times so that the end user can then query, slice and dice the data as they need. Although no Indian deployments exist as per my understanding, the architecture is ideal for our scientific use cases. It would reduce duplication, enable lightweight clients, including mobile and web apps, to be developed, and promote fair data workflows across ministries, academia, and startups. The next standard is called the OGC API Process Standard. It is the modern successor to the OGC Web Processing Service, again built for today's API-driven ecosystems. It allows you to expose geospatial models, algorithms as reusable services. For example, you have an buffering algorithm, you have a hydrological model, you have an image classification algorithm, or even you have your AIML routine. So how do you make this available easily so that the user can come and run a query and make that routine run, right? So this open standard makes that possible. And this standard supports both simple and advanced workflows and is already implemented via a lot of open source and commercial tools. And what's powerful is that the users don't need to handle the raw data nor implement the algorithms, because the data and the algorithms are at where they are supposed to be. The user is only asking certain query, sending certain query parameters to the algorithm. The algorithm is then going, fetching the data, running the process, and then giving the end result to the user. So this implementation for India can be significant. Agencies like the national weather agencies, national earth observation agencies, and research institutes can use OGC API process to publish validated models, example, a flood simulation model, a slope stability model, etc., as a service that can be called by others. So platforms like Bhuvan already implement the older generation of OGC web processing service, but then there is a scope for modernization even in such areas, and even in projects like PM Gati Shakti, and integrating these APIs can add a lot of value for a lot of end use cases. Crucially, this enables cloud native workflows, so no large downloading of data, no downloading of large data sets, no need for writing their own algorithms. They can just send a query and get an output based on a trusted data set and a trusted algorithm. And this modernizes the e-governance, decision support, making models transparent, reproducible, and easier to scale across ministries, states, and even multiple research projects. So what you saw till now were various standards that can enable the S&T innovation in India. Here in this slide, you will understand about the OGC innovation programs that actually undertake run the innovation programs as well. So these programs brings together governments, academia, and industry to co-develop new solutions, validate emerging standards, and rapidly de-risk geospatial innovations. So we have various types of innovation programs called test beds, pilots, code sprints, and OGC facilitates real-world experimentation across topics like disaster response, digital twins, geo AI, and many more. And these are not just technology demonstrations; they are foundational to standardizing the next generation workflow. What makes these innovation programs unique is its impact, and many standards that we have just discussed today were validated through our innovation projects before becoming official standards, or before becoming a mature standard. So it's a continuous R&D loop that directly feeds the open standards ecosystem, and the OGC innovation programs are meant for that. Again, for India, this presents a compelling opportunity in geospatial research and development. We don't just need to consume global standards, we can shape them, and we can profile them as per our needs. By initiating India-specific pilots for various use cases, say monsoon flooding forecasting or city-scale digital twins, Indian agencies can solve domestic priorities while feeding insights into the global standards process. So the call to action here is very clear, that we must not remain passive consumers of standards. By engaging with organizations like OGCs and the OGC and the innovation program of OGC, India can embed its priorities on S&T innovation and become a leader in the global geospatial future. So one of the current programs that is running is called the Open Science Persistent Demonstrator, which is a landmark initiative led by OGC, NASA, and ESA to make scientific workflows transparent, reusable, and portable across platforms. This is what actually open science looks like in action. The OSPD connects multiple Earth observation and high-performance computing platforms using OGC APIs and containerized workflows. The result will be a live cross-platform ecosystem where researchers can rerun an atmospheric simulation, let's say, made for an European scenario, deployed in a European environment, take it and try to deploy it easily in an US environment, along with full provenance and repeatability. So this is the kind of things that we are looking at when we are talking about open science. This isn't just a technical elegance. The broader impact is that integrity, trust, and reproducibility in science will be there. And OSPD supports publishing APIs from notebooks, linking datasets with documentation, archiving workflows for public inspection. Again, for India, this model is hugely relevant. We have diverse platforms in India, but workflows against these platforms, across these platforms are very fragmented. Adopting this demonstrator model locally can help unify platforms, promote reuse, and align with global scientific practices. So as India scales up its digital public infrastructure for science and climate, embracing these reusable workflows built on open standards can unlock major efficiency and trust benefits across numerous agencies, and especially the research ecosystem. So where do we go from here in India, right? The road ahead lies in making interoperability the default, something that's expected and not exceptional. This isn't about picking a single tool or a standard. It is about building a culture of openness, reuse, and alignment across our ecosystem. The first thing we can do is embed standard compliance into everyday practice, even into R&D. Every data platform, mission, or a scientific project or a research project, whether it's on climate, weather, water, urban systems, or space, should treat open standards as a basic requirement. That shift would ensure the long-term value, uh, easier integration across departments will be possible, and readiness for scaling those pilots to national efforts will be possible. Second is there is a need to build capacities. We invest in training teams. We should invest in training teams not just on tools but also on standards-based design. Whether using commercial or open source tools, the focus must be on interoperable workflows that can again scale. Again, the third is to co-develop solutions. We don't have to wait for global standards to evolve. We can also lead from the front as India. We can launch India-specific test beds, contribute to standards design, solve our own local challenges in a globally consistent manner. And OGC makes that possible. And finally, we should align with national priorities, whether it's Gati Shakti, digital twins, or climate missions. Standards are the glue that binds data, platforms, and insights. So by embedding standards very early, we future-proof our systems and amplify the impact across domains. So the message is simpler. Open standards are no longer optional. They are strategic. They help to build a strategic infrastructure that India needs. And India has the talent and scale and the vision to lead this transformation globally is what we believe at OGC. And we invite everybody in the community to take the lead. So I thank the CDPG team again and all of you today joining the webinar for the time and attention. I hope this presentation has shown that open standards are not just technical protocols, they are strategic enablers for India's S&T ambitions, that is science and technology ambitions. As I've demonstrated, we have seen standards like GeoTIFF, NetCDR, API EDR, API processes that are already powering real-world platforms and use cases. Not just abroad, but in a ways in India as well, where we can adopt, extend, and lead. And these standards can bridge the silos, enable reproducibility, and build a common language across the researchers, government programs, and technology developers. As OGC, we are more than a standard-setting body. We are a global community of practitioners, and India is uniquely positioned to shape this future. Whether through co-design pilots, participation in working groups, or test beds aligned to India priorities, the opportunity to collaborate is open, and this is the right time. And we see immense potential in the Indian science and technology ecosystem, and we believe open standards will be key to unlocking it securely, scalably, and collaboratively. And this conversation shouldn't just end here. If you're exploring new workflows, planning national infrastructure, or rethinking how science should reach society, we invite you to connect, contribute, and co-create along with us. Thank you, and we look forward to working with you. I'm now happy to take questions or hear your reflections. Thank you very much.
Thank you, Harsha. That was amazing, actually. And one takeaway from this presentation is I figured out that, when you speak of OGC and geospatial standards, essentially, they are not restricted to the geospatial ecosystem in some sense, right? When you talk of open science, it encompasses a lot of things, and that's as you rightly said, that OGC is not simply a standard setting organization, but it is enabling a whole ecosystem where all other verticals will also get benefited. This is amazing, actually. Amazing work being done by your team. So I'll open the session now to any questions which people have. You can unmute yourself, or you can raise your hand, or even you can text your question in the message, and I'll read it for you. Yeah, I see there is some. Yeah, thank you, Dr. Srinivas Rao. I think he has.
He has a question. I guess he's raising his hand.
Yeah, thanks, Dr.
Yeah.
Nilkant. Yeah. So you want to say anything, Dr. Srinivas?
Yes, I want to ask that small question. Actually, that as an inquiry, we have the repository of the GOT files. So as on today, we are distributing the data to the users as individual files. So how to make it that database kind of thing? Is it possible?
Sure, Mr. Srinivasrao, I can take this question because it's actually a very little long stretch discussion. I would be glad to have this discussion with you offline. For all of you, I'm dropping my email. Again, I'm sharing my screen. There is an email of mine available in the in the presentation. So you can reach me over that email, hmdiraju@ogc.org. All your technical questions you can here. And again, I just want to tell that JD's team in India is actually building a brilliant infrastructure. I think it's a good opportunity also for JD to briefly talk about it and how you are enabling open standards, because that would partially answer Mr. Srinivas's question, because stack is a key part of it. JD, you want to quickly answer that?
Yeah, so Dr. Srinivas, thank you for your question. So I don't know if you've heard of this platform called Integrated Geospatial Data Sharing Interface, or GDI in short, right? So this is an initiative, sir, of Department of Science and Technology, and we at CDPG at Indian Institute of Science have developed and deployed this system. Essentially, the idea is to connect the data providers and the data consumers in a interoperable and secure and consent based manner. So if you allow, sir, maybe I can give you a walkthrough someday, like half an hour, and I think that would be good.
Yeah, definitely, sir. I will touch with you.
Yes, sir. Yes, Srinivas sir, because there is a implementation they have done on a thing called STAC, Spatial Temporal Asset Catalog. So that allows you to actually share Earth observation data easily, and it also enables data to be queried easily using metadata, such as, for example, time of the data creation, parameters, many more. So I think it will be very good for you to explore with the JD and team on that, sir.
Okay, definitely. Thank you.
So Praneeth has a question, Harsha, for you, Mr. Praneeth. He says that would it be possible to know the top 10 or 20 business problems, civil in Indian context?
This is there is something called out of syllabus. I think it is out of syllabus for me, because this I think anybody and everybody can think about problems statements in India. But from a geospatial perspective, I think it'll be good that we bring that to the table, and then again, the JDN team can allude to that through Project Dronagiri. You're trying to solve some problems. JD, can you briefly talk about the use cases in Project Dronagiri
I have to check if, I don't know if Deepthi is there. She can tell you. I don't recall the problems, but I know the sectors which have been selected, and that is agriculture. Yes. One is mobility and one is livelihood, right? So the primary focus, Mr. Praneeth, is right now to build solutions for these sectors, right? For example, crop yield estimations, figuring out the employment opportunities based on your location, and and traffic management and all those kind of things. But I don't know the details. I can share it with you if you share your email ID with me.
Yes, that'll be awesome, Jyotirmoy. And
Yes,
sure.
yes, yeah.
Yeah, actually, Project Dronagiri, Mr. President, is a initiative from GDPDC along with many other stakeholders. And agriculture use case is very interesting because they're trying to also bring the insurance companies, the farmers, the geospatial solution providers, and try to see how can data exchanges like GDI can solve problems for such very complex use cases in India.
Got you. Thank you. Let me get in touch. Yeah, to get the narrower use cases.
Yeah, sure. Thank you very much, sir.
So, Harsha, you mentioned that cloud optimized geotiffs are sort of a de facto in industry, but you don't see a lot of acceptance in the public sector. So, why is it so?
It's from an analysis perspective, I believe, right? Because in the what you call in the startup domain, because they are mostly looking at it from an application-driven perspective, right? And then how do you take away the loads on your servers and only look at chunks of data that you need for your algorithm or for your application to consume? That optimization was seen very early in the commercial sector, both in the Earth observation space, in the drone space, especially because when you let's say captures a drone data, it's a very huge data, a DEM file or an area of interest file is very huge. So how do they quickly host it on an Amazon cloud service or any kind of a container and then give a URL so that the client can then easily visualize it on a web browser, right, to look at the data. So I think these kind of things earlier has made those kind of things. For example, in India, we have huge projects where drone surveys are being done, right, and the data is being collected. One is the data outputs, I think, should be in COGS and should be served as COGS again, so that there again is optimization, a lot of optimization on the server side for the data distributors, such as, for example, NIC or Survey of India or anybody else. So I think this is with time. I think COGS will also become de facto in the government space.
Yeah, there's one question, Harsha, from one Ms. Dhruvi. She's asking, what is the difference between open and closed standards? It's a good question. Maybe you can cite some examples.
Yeah. So the name Open Geospatial Consortium comes from the openness of what we do. So whenever a standard is getting created, what we do is we have the community openly comment on them, right? The community openly provides a feedback on that. That is one key aspect of openness. Second is whenever we publish a standard, that standard is openly available. There is no royalty for you to access that standard. Anybody and everybody across the globe can go to the OGC website, access the standard, download the standard. And even now the development process to standards is open. All the standards development happen openly on GitHub. So that's what we call when as open standards. And other standards are there where you have to pay a royalty to access the standard. So in case of OGC, that's not there because our business model is we are funded by our members and it's mostly driven by community, and that's why our standards are largely open.
Harsha, I mean, can you cite some such closed standards? Because this word itself is very rare to be used, right? Like it's always open standards. Closed standards, I mean, are there any in industry you are aware of?
Yeah, that's a good question because sometimes industry formats are also sometimes certain formats, certain data formats become so prevalent that it becomes a de facto, it becomes a standard. That means everybody and anybody starts supporting. For example, in the document space, we know that docx or .doc, right? It is owned by Microsoft. It's not an open format. PDF, it's owned by Adobe. It's not open format, right? But still, most of the providers support it. Similarly, we have formats in the geospatial space which are very relevant. For example, we have DGN on the design side, we have shape on the what you call on the geospatial side. So we have these formats which are standard still owned by the companies. So here these are royalty free standards owned by the community, and then OGC maintains these standards.
Okay, yeah, thanks. I think Dhruvi, you have got your answer. Thanks, Harsha, for this elaborate explanation. We'll wait for a few more questions. Till that time, I have another question for you, Harsha, that you spoke about this open science persistent demonstrator, right? Something called like OSPD, and which is like one of the way to enable open science, right? And this, I have been hearing open science of late quite frequently in many discussions, right? So I understand that, again, the intention here is to have all the scientific data or scientific standards open, free, accessible to everyone under maybe some licenses. Did you get anyone use these? I mean, can you cite an example of people using open science in India, like someone using OSPD, for example?
OSPD is just phase 1 of the initiative concluded in 2024 within OGC. This is the phase 2. Within India, I have not come across this concept largely, but we are seeing a smaller step on the little bit downstream side, whenever people are publishing research papers, right? Whenever there is an output data, they are now publishing that data which they have consumed in the output formats openly. So that is a very small step towards that openness. So it is a call to action for all the researchers, right? Whatever research reports they are publishing, the outcome should not just become fancy maps as in their reports as PDFs. The actual data sets and the actual outcomes should be made available in open formats. There are certain research websites that I've come across recently. I'm not able to cite immediately from my brain, where even researchers in India, right, from IIT, I've seen a professor in IIT Delhi, I guess. He does a lot of research on atmospheric sciences. So he and his team, whenever they publish a research paper, all the data is the outcomes of that paper, whatever that Excel data, the map data, the raw data, all that, they are now publishing it as packages. So this is actually a very small step towards open science. Open science is a much bigger term, because in open science we are also saying reusable software components or reusable, let's say, what you call packages which can be deployed across multiple servers without with minimal configurations, right?
Understood. Very nice. Yeah. Okay, maybe we'll wait for another minute if there are any questions. Anyone from CDPG team?
One query from my end. This is Praneeth here again. I'm sorry. So when we were speaking about the APIs,
Yes.
So the endpoints as to where or how we can access these APIs and how to get the data, is that something which is publicly available at this point of time?
So OGC APIs are only towards developing software products. So the data is still owned by the data provider. OGC, these APIs does not talk about that. So I will share. Surprisingly, I'm not able to put anything in the chat. I want to put the OGC APIs website in the chat window, but for certain reasons I'm unable to copy. Oh, I'm able to do that. So, Mr. Praneeth, I've just shared a website link, right? please access that. And if you have developers at your end who want to explore OGC API, the second website is also good, where it talks about various APIs, how those APIs can be consumed to create your own products or solutions. And also, if you go to the GitHub repositories for each of the APIs, it will show the server-side implementations and the client-side implementations. So not all people will develop their own software solutions, right, from scratch. They want to use readily available software components, either the server component or the client component. So at each of these websites, there is a list of the servers that support these APIs, both on the commercial side and the open source side, and also the clients that support on the commercial side and the open source side. You can have a look. And also, there is one more site, OGC, just a minute. We have a list of products that actually are complied to various OGC standards that you can have a look into. I'm also putting that chat in the link. So you can also look by standard, what are the products and services that are deploying various standards.
Awesome, thank you.
That means readily deploy these products into your apps.
Excellent. A follow-up query is, excuse me. So when we look at APIs and their consumption, so I have not yet explored these sites. I will definitely check them out. Is there a way to check on the metrics or analytics of, let's say the top 5 or 10 most used APIs, or metrics or statistics about the consumption?
Actually, these are not APIs in themselves. These are API standards. I think API standards are the ways to create your own APIs. And then, for example, using those standards, developers create their own API-based products, right? So, JD, you have some examples?
Yeah, I think, like, for example, in a data exchange, Mr. Praneeth, right, we have a auditing mechanism, right? So let's say that there is a data set which is being accessed multiple times, right? And so I mean, we have a mechanism where we can tell you which data set has been accessed maximum, which APIs were used to access that, what was the volume of data being fetched from the exchange, what were the number of API calls, etc. I think, is that what you are asking?
Yes. So
yeah, that is doable. Yes, 100%.
Okay, but would you say that is public data as of today, or is that something which can be provided on request?
So there are two cases. One is case number one, where there is a public data, right? Which again does not mean that it is open in the sense, like, even if it's public, you have to register to access that, register on the platform, right? And then let's say the provider who is giving that public data, if he wants the metrics related to that particular data set, we can provide that. That's one. Case number two is it's a restricted data set, which means you need explicit permission from the data provider to access that data. So in that case also, those restricted data sets, who has accessed that after, of course, all the approvals, that can be provided. So yes, so the answer is whether it is public, whether it is open data, or whether it is private or restricted data, all these matrices related to the APIs can be given, and that's the value which a data exchange brings vis-a-vis open data portal.
Okay, awesome, thank you. So just one last query, if you don't mind. So is that data portal part of any of these links, what all of you have shared?
So to access GDI, you have to go to geospatial.org.in, right? And once you land there, this is the data exchange platform, right? You can then have, you can then go to explore data sets, right? And once you go there, you can just create one single credential. username, password, and then start accessing the data sets. A client ID and a client secret will be generated, which you should keep it with you. And there are videos, there are walkthrough guidelines, and I'll be very happy if some of you land on this platform, start using it, and give your feedback to us so that we can improve it in the days to come. Yeah.
Absolutely.
There is one more question, I think, from Akash.
Thank you, Mr. Harsha, for the insightful session. I had a question for Dr. Jyotirmoy. This is regarding the GDI and the IUDX platform. So the providers we are seeing are very limited in nature, and the data sets are also very limited. So sometimes the providers don't give access for 3-4 years. I mean, like we have to go visit them, and then the access are given in a different format, for example. So is there a way wherein when we make these standards or when we put in these efforts, we can have some kind of like a framework wherein this becomes compulsory for all the providers to kind of like be onboarded on the platform? And
yeah.
Also, if I may to extend to the project Dronagiri, so startups who were not able to contribute to the challenges which existed, I think the deadline has gone. So since you also mentioned mobility, which is a very important interest to us, so is there a way where we can access those data sets, build our own models? Is there any opportunity there?
Yeah, thanks, Akash. So there are two parts of your question. The first part is that you have asked for access to some data set which you have not received for a long time, right? That's your concern, right? So see, if you look at the policies of late, one of the policy recommendations is that the public data sets which have been created using public money, using taxpayers' money, should be available to the public based on fair conditions. Having said that, still it is not a clear mandate, and therefore you might have faced this kind of issues where you have requested for a data set but you have not got it. Am I right in my understanding? Right.
That's absolutely correct. Yes.
So
so we have to actually go and interact with these providers instead of everything being online. So there's
no to solve. We don't want anyone, and see, these platforms like IUDX, edX, GDI are for application developers. So the mandate here is that developers like you, startup people, should not have to go knocking at the doors, getting data. With a single credential, they should have access to good quality interoperable data, which is from diverse sources. That's the broader goal. Now, there are challenges, right? The challenges is more at a policy level than at a technology level, right? So if there is a clear mandate, I think this should not be problem. It should not be a problem. But we can only help, from a tech point of view. So that is, I think that's a response to your first question. You asked another thing, right? Can you please repeat?
Yes, thank you for the response. So this is regarding the project Dronagiri.
Yes.
So the starting challenges have ended now. So there are empaneled startups, and there is still the data sets which are there and certain use cases which are built. So is there a possibility to contribute towards existing use cases, or if we can access the data sets, we can build our own?
Are you part of the Operation Dronagiri?
No, I have not participated as yet.
You have not participated. So for Operation Dronagiri, like as you know, these startups have to build something based on the data sets which is already available in GDI or otherwise. So if you are working in the mobility sector, there are two things. One is I can connect you to our mobility team, right, who are working closely with the Bangalore traffic police to come up with some solutions, BTP, right? That is one. You can drop your email to me, or maybe write to Deepthi, right? The other thing is that these data sets are already available, right, on GDI, right? So if you are looking to build something, you don't have to be a part of Dronagiri. Dronagiri is only a subset of the bigger platform, right? So, yeah, I mean, more than 1,300 data sets are there at your disposal at this point of time.
That's very useful, sir. I'll definitely explore this and get in touch over email. Thank you so
Sure,
much.
please drop me a mail and I can respond.
Yeah, I put a chat here, JD. I recently come across this directory by Mighty. It's called APIs.
Correct.
It has various APIs. For example, in case Akash, right? Akash, you can go and explore. There are APIs on category of transport and infrastructure as well, right? So you have various categories of APIs. So if any of those APIs, because I saw that you're from the mobility side, that might be valuable, but those are non-geospatial. Again, this challenge remains, which I think I'll take a moment because JD is here to talk, right? We have seen JD data.gov initiative, right? Which right? And then the expectation is that all the data would be accessible there. Then we have these various parallel initiatives on data sets, and then data not talking to the data.gov. Similarly, we see now on APIs. I think there is a good possibility for the ecosystem to keep contributing over there as well. Like we may want to publish our own APIs there so that people not only come to our exchanges or data houses, but they can also see that there is an API available from there. I think there's a good opportunity for us, the community, to explore such kind of things where we also go into the broader platforms where that larger conglomeration is happening. That's my 2 cents.
No, certainly. And there's a monetization angle to all this as well, Harsha. That the moment a data exchange reaches a critical mass of data sets, right? And there are valuable data sets, dynamic, updated, high quality. And even after that, and I've seen it myself, even if after that you monetize it, right? People are willing to pay actually, right? We have the capabilities of integrating payment gateways, and if needed, we will do it for the data providers, right? So I think in the times to come, these challenges will be ironed out, right? People will start taking notice of the data platforms and the value open standards also bring. Right, that is, I think, a lot of what should I say, evangelism or awareness has to be brought, and that is our small step to invite you today, Harsha, to give us a peep into the world of open standards and how important they are. And I don't see, personally, I don't see any science or tech going forward without openness. Open AI also became open a couple of days back, as you know, right? So that's how the society progresses, right? And thank you so much for your time, Harsha. And I'll close it. And you will also be able to, have the recording on YouTube in a couple of days. So thank you so much. I'll close the session now.
Yeah, thank you to all participants, again, the hosts, for bringing OGC onto the table. Have a good day, everyone. Bye-bye.